when a plane polarized light, it is passed through few materials, for example, let us say quartz crystals, the plane of the emerging light is not the same as the plane of the incident light. So which means that the crystal has rotated the plane of polarization of incident light. This phenomenon of rotation was noted in 1811 by a French physicist named as Francois Arago, and it is called as optical activity. So what is optical activity? We can say it is the ability of a substance to rotate the plane of polarization of a beam of light that is passed through it, or we can also say the ability of chiral substances to rotate the plane of polarized light by a specific angle as optical activity. Let's see few examples of optically active solutions. For example, glucose solution, fructose solution, turpentine, etc. they are optically active. Whereas water is optically inactive. This is because water has got a plane of symmetry, so it is achiral and does not have optical chirality. So we can say that chiral compounds are optically active and achiral compounds are optically inactive. Now, why does the plane polarized light rotate? This is because of the interaction of the electromagnetic radiation of the polarized light with the unsymmetric electric fields which are generated by the electrons in a chiral molecule, and the optical activity is studied by a polarimeter. Now, this optical activity of a compound, which is proportional to the concentration of the compound in solution, the length through which the light traverses through the solution, the wavelength used for the measurement, that is lambda, and the temperature at which the measurement is made. And in a polarimeter, usually sodium D light is used for the polarimetric measurement. Polarimeters, they compute the optical activity by passing the monochromatic light through two polarizing plates, and sodium light is used because it produces monochromatic light of 589 nanometer and also the energy output is high. This phenomenon of optical rotation was studied in detail by Biot in the year 1815, and he proposed the laws corresponding to optical rotation. The amount of optical rotation that is produced by an optically active substance is directly proportional to the thickness of the crystal or the path length which is traversed in its rotation. Therefore, we can say that theta, which is the angle of optical rotation, is directly proportional to L, the path length, that is theta is directly proportional to L. And the amount of optical rotation, that is theta, is also directly proportional to C, where C is the concentration of the optically active solution. Also, theta is inversely proportional to the square of the wavelength of light used, or we can say theta is proportional to 1 by lambda square. And let us see some of the applications of optical activity. Optical rotation or activity is used to determine the percentage of optically active substance in the solution. In fact, the sugar level in the urine of diabetic people can be determined by calculating theta of the plane of polarization. And when optical activity as a function of time is plotted, we can determine the kinetic reactions. And in organic chemistry, it is also used to plot ORD curves for various ranges of lambda, and this feature is used in analyzing the structures of molecules. To sum up, we have seen that the ability of a substance to rotate the plane of polarization of a beam of light which is passed through it is called as optical activity. Thanks for listening.